Hi, I'm Ronnie, and I'm joined by my colleagues, Terence and Todd. We're thrilled to be here today. We really appreciate the time you have invested in talking to us, sharing your experiences, and providing feedback. Privacy and security are fundamental qualities that we, as app developers, should care deeply about as we build our apps. Android's basic frameworks provide a deep level of security for your app and privacy for your users. And we continue to push each year with new functionalities for privacy and security. This year is no different. Our focus on privacy and security pays off. Last year, we prevented 1.2 million policy-violating apps from entering Google Play and banned 173,000 bad accounts. We also prevented 2 billion in fraud and abusive transactions and helped fix 500,000 security vulnerabilities for apps with a combined install base of 250 billion installations. In this session, we will explore our latest privacy changes and share specific approaches to building more privacy-centric apps. Then, we will cover ways to optimize security and performance with special permissions. And finally, we will review our latest security changes, followed by concrete actions you can take to prevent common security pitfalls. We, on the Android team, believe privacy is centered on the user. Over the years, we have added many features to provide more transparency to users regarding which apps are accessing their data, as well as how their data is being used. In Android 12, we introduced the privacy indicators, which show when apps are accessing data from the device's camera and microphone. Users can simply tap on the indicators to see which specific apps are currently accessing the data from these device sensors. Android 12 also saw the release of the Privacy Dashboard, a one-stop shop that allows users to see which apps are accessing data, which permissions apps are using, and when that access is happening. Then, in Android 13, we unified security and privacy settings into one hub. This hub makes it easier for users to understand the privacy and security status of apps and their devices. Last year, we also announced the Data Safety section in Google Play, a transparent way for developers to show if and how they collect, share, and protect user data. This information appears in the app's listing in Google Play. Since the launch, we've seen millions of users engaging with Data Safety section every day. And it's become an important way for users to evaluate an app's safety before installing it. In Android 14, we're taking transparency one step further by adding the data safety information directly to the permissions dialog. Starting with location permission dialog, users will see a new clickable section that highlights when app shares users' location data with third parties. This is a simple way to make users aware of an app's data privacy practices and help users make more informed choices when deciding what permissions to grant. In addition, users will get a monthly aggregate notification when their apps change their location sharing practices, like when they start sharing data with third parties or use it for ads purposes. In Android 14, the experience will only cover location sharing updates, but we're evaluating how we can expand this further to other permission types in future releases. The data safety information is provided by the App Store from which the user installed your app. If your app was installed from Google Play, this information comes from what you've declared under the data safety form in the Google Play Developer Console. If your app was installed from another app, the App Store will be able to provide a mechanism to pass along this information as well. We encourage you to review your app's location data sharing policies and take a moment to make sure that your app's safety information is up to date. We also just announced the new data deletion feature in Google Play, which gives users an easy and consistent way to request that their data is deleted both inside and outside of an app. It's a great way for you to show users how you treat their data responsibly and further build trust in your app. We are adding this new feature to Google Play's Data Safety section, where users will be able to identify privacy control features that your app offers and control their data by submitting requests to delete their account or other personal information. With our new Google Play policy, all apps that give users a way to create an account from within an app must also give users 2 ways to request for their data to be deleted. First, an in-app path, and second, a web link so users can still request for their data to be deleted if they've uninstalled the app. With this new data deletion feature, you can give users more choices. Instead of only offering users a way to request for their entire account to be deleted, you can include an additional option for users to clean up their account and request that other data be deleted, like activity history, images, and videos. Android is continuously focused on protecting the data that users care about the most. And each release introduces new transparency and control around the way user data is being collected and used. In addition to adding more transparency and control features into the platform, we rely on you, the developer, to protect the privacy of our users and improve their experience within your apps. Here is Terence with more information on how you can enhance responsible data collection and usage for your apps.
Thanks, Ronnie. Developers like you represent an important pillar of the Android privacy story. Let's go over some developer-oriented features, statistics, and showcase how you can build privacy-centric apps. First, a quick recap on storage. In Android 13, more granular permissions for accessing shared media files replaced read external storage. But why request access to all of a user's media when you can simply use the privacy-forward photo picker? In fact, it's even available for devices with Google Play services running KitKat and above. In less than 5 lines of code, your app can launch a media selection intent and give users the option to share specific photos and videos using a simple UI optimized for media content. The upcoming months, cloud media providers like Google Photos will also be supported. The photo picker will seamlessly integrate photos and videos from cloud media providers into the selection grid, eliminating the need to locate and download backed up photos and videos in a different app. Users will even see their custom and shared albums in the Album tab. Happy to announce that with the launch of these new features, over 15% fewer apps are requesting access to all user photos and videos today, compared to 2019. If you have wondered whether you should reduce storage access for your apps, we strongly encourage you to do so. To further enhance users' control over their media, Android 14 will allow users to grant access to selected photos or videos even when an app requests broader visual media access. Other options in the dialog won't change from Android 13, and apps that already hold relevant permissions will retain access. If the user grants only selected access, they will choose which files to share with the app. Those files will then be accessible via Media Store. To avoid additional complexities, we strongly encourage developers to implement the photo picker instead of requesting broader storage access. If maintaining embedded UX control of storage is crucial, you must update permission handling logic to avoid access issues. If the user chooses selected access, apps can request for visual media permissions again to prompt the user to share more photos and videos. We recommend that you declare the new user selected permission in your manifest to manually reprompt for more media in context rather than relying on system default logic when the permission is not declared. Here's the code to handle visual media permission grants if your app targets SDK 33 and above. If the new user selected permission is granted, but media permissions are denied, then the user has chosen selected media access. Request for more photos and videos by re-requesting for media and the new user selected permissions together. In response to feedback, we are excited to introduce a new privacy-preserving API to detect user screenshots. This API notifies apps when screenshots are triggered from a hardware button combination without accessing the user's photos. Apps only need to add the new detect screen capture install time permission. If you are currently using less private workarounds to detect user screenshots, we strongly encourage you to migrate to the API and reduce or eliminate your app's storage access. Remember to inform users that your app can detect when to take a screenshot so they're not surprised by the system notice. Let's dive into the adoption process. The API lets apps register callbacks on a per-activity basis. First, implement the callback by overriding the on-screen capture function. Then, register the callback as part of the activity lifecycle, for example, in the activity's onStart function. Lastly, remember to unregister the callback in the activity's onStop function. In addition to storage improvements, we have seen users take advantage of Android's increasing focus on protecting user data across other permissions as well. For example, we've seen a sustained increase in users granting permissions, only this time across all 3 eligible permissions: location, camera, and microphone. For microphone in particular, almost half of all granted permissions were provided through only this time access. With such a clear desire from users to limit data access by apps, let's review some privacy best practices that will set your app apart. Consider downgrading location access, as coarse access is sufficient for most functionality, such as suggesting nearby events. Use the action image capture and action video capture intents to allow users to take images and videos using the system camera rather than requesting camera permissions directly. To identify devices, use app scope identifiers like carrier status or mobile subscription status instead of non-resettable hardware IDs. For pairing over Bluetooth and Wi-Fi, leverage the new dedicated permissions and add the never for location flag if you don't use data from access points to derive location information. Use the SMS Retriever API for one-time passcodes and the action dial intent to allow the user to place phone calls without requesting permissions for direct access. The data access auto APIs can identify unexpected data access, even from third-party SDKs and libraries. Remove permissions that your app no longer uses by calling the Revoke Self-Permission OnKill API. Non-dismissible notifications are 20% more likely to be blocked by users, suggesting that excessive amounts of such notifications degrade the user experience. In Android 14, notifications with the flag ongoing event flag will be dismissible when the device is unlocked, although they will still be non-dismissible on the lock screen and protected from the clear all notification action. There are some select exemptions listed here. Please check out the developer documentation for more information. Now, let's discuss the latest in special app access permissions and how they optimize the security and performance of your device. Special app access permissions are different from install or runtime permissions and guard access to sensitive system resources. To ensure maximum protection and enhance device performance, many of these permissions are turned off by default. Apps can request access by directing users to the relevant page in system settings rather than directly prompting for access. There are some examples of special permissions here. In Android 14, we're disabling the ability for newly downloaded apps to launch full screen intents and schedule exact alarms by default, although they can continue to request special access as needed. Apps that already hold permissions will retain access. The use full screen intent or FSI permission will transition to a special permission, as FSI notifications are highly visible and pose security risks if misused. App stores will control whether newly installed apps can obtain access by default, and the newly introduced play policy will only enable FSI for apps that primarily place phone calls or trigger alarms by default. The Schedule Exact Alarm special permission, required to schedule exact alarms, will also be denied by default to improve battery life and performance. Call these functions to ensure that your app holds these permissions before showing FSIs or setting exact alarms to avoid triggering exceptions. Use these functions to link users to the relevant page in system settings, where they can choose to enable permissions. And with that, I'll hand it over to Todd, who's currently at a top secret, super secure location, to talk more about how to protect your device and make apps safer by default.
Hi, I'm Todd, and I work on our security team. Protecting Android users is a shared responsibility between Android and app developers like you. The word exploit means dramatically different things when we consider different types of apps. Exploits generally fall into 2 categories: an outside entity attempting to attack your app and harm your users, or individual users who are acting in bad faith when interacting with the application. This year, we're introducing changes to make the ecosystem safer by default, and we can't wait to see the positive impact on users and developers. Starting with Android 14, apps with a target SDK version lower than 23 can't be installed. By requiring apps to meet these minimum target API level requirements, this change improves security and privacy for users. On devices upgrading to Android 14, any apps with a target SDK version lower than 23 will remain installed. Attempting to install an app targeting a lower API level will result in an installation failure and an error message in Logcat. If you need to test an app targeting an older API level, you can use the documented ADB command. Why? Malware often targets older API levels in order to bypass security and privacy protections that have been introduced in newer versions of Android. For example, some malware apps use a target SDK version of 22 to avoid being subjected to the runtime permission model introduced in 2015 by Android 6. This Android 14 change makes it harder for malware to bypass security and privacy improvements. This will help protect your apps from malware that may have abused old APIs. And for Google Play developers, you're already updated to target your SDK level to align with our annual policy, so you won't need to make changes to get this added protection for you and your users. To further protect the ecosystem and encourage taking on security enhancements, Play developers must target a recent API level in order to submit a new app or submit an app update, and target a recent API level in order to remain distributed to all users on Play. Making Android safer means protecting users from web attacks, and safe browsing protects users from falling victim to phishing attacks. The API checks URLs the user visits against a list of known phishing URLs and warns the user with a full screen message. Safe browsing provides protection on many commonly used browsers, including Chrome, Safari, Firefox, and Android WebView. The current version of safe browsing works by checking every site visit against a locally stored list of known bad sites, which is in turn updated every 30 to 60 minutes. Safe browsing exists on your device today, and we are bringing new functionality of live threat detection to further improve this service. Many phishing domains exist for 10 minutes or less, which means that real-time analysis will dramatically enhance the protection we can provide the ecosystem. The new version works by checking navigations against an on-device likely safe list. This local allow list has increased in size since Android T, improving query performance. If it doesn't see the URL on the likely safe list, it sends encrypted hashes of the URL lookup expressions to the safe browsing API, and it sends a response back to the client. We're working with early testers now, and it's coming soon. When we become aware of a pitfall that affects many Android developers, or an improper implementation causes unanticipated interactions to happen on devices, we must find a solution to minimize how this affects the ecosystem. The largest security changes you need to be aware of in Android 14 all revolve around helping protect against unintended interactions between apps and other apps, or between your app and nefarious code on a user's device. Most changes were generated from our Google Play Security Reward program. There are 4 key changes that you should know about. In Android 13, we introduced a flag that developers can use to indicate whether a broadcast receiver should be exported or not. On apps that target Android 14, developers must include this flag. Also in Android 14, we've made implicit intents only available to exported components. On previous versions, apps could use implicit intents internally, for example, to organize their own components. However, the problem we see is they forget to specify a package name when firing the intent. This can happen with broadcast receivers or activities. The top intent shown on the screen can be intercepted by a malicious application since it allows any app to start the activity, not just the calling app. We've also made changes to dynamic code loading and background activity launching. If you use these features, check out our documentation. One thing that's important to note is that your SDK dependencies and third-party libraries must also make the updates required to each version of Android in order for you to target the new version. To make sure everything is working as you expect, you should invest as much as possible in testing. Over time, we've seen more developers wanting to check that user actions and server requests are originating from an unmodified app binary that's running on a trustworthy device. This is typically to protect users from attacks and data theft, and for anti-abuse purposes, such as preventing fraud, preventing cheating in games, or reducing unauthorized access. The Play Integrity API provides a cryptographically signed response regarding the integrity of the installed version of the app and device your servers are talking to. We're introducing standard API requests as a new way to obtain integrity verdicts alongside the existing way of requesting them, which we're renaming Classic API requests. The new standard requests use smart on-device caching on the user's device by Google Play to reduce the latency of the response by 10x. Making responses faster is the most requested developer feature for Play Integrity API, so we're really excited about this. Standard requests can be made in the Kotlin programming language, Java programming language, in unmanaged code, and with the Google Play Games plugin for Unity. You can start reading the docs today and start making standard requests in the coming weeks.
With each year, we hope to simplify and clarify the way developers interact with Android. In doing so, our goal is to make it easier to build secure apps. Creating a safe and privacy-centric experience is a shared responsibility between Android and app developers. We must work together and communicate to create the best ecosystem. Now, let's take a moment to summarize everything we discussed today. Here are the main takeaways for developers. 1. Target new versions as soon as possible to take on the latest security enhancements. 2. Pay attention to data being requested and respect user choices. 3. Choose privacy-centric alternatives whenever you can. And 4. Minimize access to data. We appreciate your time today. Please make sure to check out other amazing I/O talks. Thank you.